Okay, so hello guys. Now welcome again to our another discussion video with mechanics of deformable bodies. Okay, so I guess everything is all clear with our first module. So that would be all about stress. So now we will be discussing another set of information maybe. So this would be a very short discussion with strain. So module 2. So actually this is just simply an introductory module. So for module 3, because module 3 is just simply the relationship between our stress, which is discussed in module 1, and strain. So strain will be discussed in this video. So medyo usara ni siya ka discussion video for module 2. And then after that is let's proceed with our module 3, so which is the mechanical properties, because we are going to investigate how strong the material is based on its stress and stress and strain, according to its stress and also for its strain ang iyahang response. So, okay, so without further ado, let's proceed with our discussion. Okay, so our topic for this video again is all about your strain. So we will just be discussing with these topics. So just a short information on what is deformation. So I guess you already have the idea on what is deformation siguro. So let's just clarify it, and also the main topic, which is our strain. Okay, so our objective here is to define stress, strain, and deformation, and how to determine strain in various problems. So di siya kayo medyo in-deep, because that would be a very basic lang a formula nga inyong hinumduman on how to solve your deformation and your strain, of course. And heads up, your strain is just simply a function of deformation. Okay, so function lang na siya sa deformation. So let's start. Deformation and strain, we are going to understand the concept of deformation, which is the main concern of strength of materials. Mo ginatong concern na, because again from the course title itself, that is mechanics of deformable bodies, diba? So materials deform. So that is why we are going to investigate on how do we determine the deformation of a material. Okay, and that would be our basis kung how strong it is to resist our applied loads. Okay, and then understand the concept of your strains. Okay, so as per module 1, alright, so okay, so a deformation daw occurs whenever a force is applied to the body. Okay, so mo gina ato reality. Strain is just simply okay, let's talk about deformation pa day. So a deformation occurs daw whenever a force is applied to a body. So there might be a change in shape and also a change in size. So as per module 1, diba, when we apply force to a body, dili lang di ay stress ang iyahang experience, diba? Kung sa previous module is we know that during the application of force by the formula force over area, it will give stress, diba? The body will experience stress. So dili lang din na stress ang iyahang experience, but also deformation. Alright, so the best example for deformation is your rubber band, lastiko, diba? Your rubber band will undergo a very large deformation when stretched, diba? That's the reality. Now, kung ano siya, it may be too obvious or too small to be unnoticeable. So, obvious siya. For example, katulagi, itong rubber band na to, kung ato siya inaton, obvious kay siya nga mo deform siya, diba? But for our structural members, alright, kanang ato ang mga beams, mga columns, when we are going to apply loads, right, to our member, ang ato ang mga deformation diha is actually natin mga deformation, but it is too small to be noticeable. Okay? Di siya kayo sa nato ma-observe because tungod sa iyang kagamay. Okay? So, deformation will not be uniform throughout the body. Thus, deformation may vary along the length of a body or material. So maginay reality. Now your deformation also dili lang siya tungod sa force, right? You will know that whenever we will be talking about deformation siguro on our next on our succeeding mga module. But deformation can also occur when the temperature of our body or our material changes. So, kung init kaayo, alright? Kung init kaayo, medyo, kuan siya, taas, di ba? Kung tugnaw po kaayo mo, gamay. Unsa daw? Basta na siya. So, a typical example of our thermal expansion is, ang ato ang door, I don't know if nakabantay mo sa ato ang door, especially if wala ganina nimo na varnishan, wala nimo butang coat. Tapos you will kanang exterior ganina siya nga door. Okay, so for example sa among abalay, alright, kanang among balay since bago pa man na siya. So wala pa na siya varnish, like bare pa lang gid siya ng kahoy, alright? So kung ting init, medyo sakto na siya sa iyang sukod, alright? Di ka maglisod og sira. Pero if muuwan or ting tugnaw kay maglisod na jud og sira, alright? Maglisod na ka og close sa iya kay huot naman kay siya. Okay? So mo na siya. So there is a figure, based on there is a figure is we have three positions. We have your vertical, we have your horizontal, and we also have your what do you call this? Diagonal. Alright? So kani before ni siya sa application sa ato ang load. Alright? So this is the application of our before the application of our load. So after the application of our load, kabantay mo nga ato ang vertical line is medyo elongate gani, di ba? Medyo may taas siya. And ang atong horizontal line is shortened. So sorry for my voice kung medyo husky kay siya because I'm gigang ko nagkasakit, so medyo lain akong tingog. So napayag-isip on ron. Anyway, so horizontal ang atong horizontal line is medyo shortened, and ang ato ang diagonal line is medyo milahi siya angle gani. Mi change ang iyahang direction o ang iya pod length is mi change pod. Okay, so that is an example of our deformation. Okay, so strain. Now, let's talk about strain. Strain is just simply the name tag of deformation. So, mas dali nimo ma-imagine ang deformation if naa si strain. So, medyo mo na ang iyahang name tag. So, we have two types of deformation. Of course, because sa stress po, diba? Sa ato ang axial stress, we have your axial. Sa ato ang stress, we have your normal stress, and we also have your shear stress, di ba? Sa ato ang module 1. Now, diri napatay two types of strain. We have your normal strain, describes the intensity of the deformation by measuring the change in length. So, kung may elongates ba siya or may contract. So, that would be our normal strain. For our shear strain, we have describes the intensity of the deformation by measuring the change in shape or the angle. So, medyo kung right 90 degrees na siya, pi over 2, so medyo may himo siyang acute angle or nahimo siyang obtuse angle. So, change in shape yun na siya, and change in angle. So, that would be our shear strain. Alright, so medyo ano na siya, self-explanatory. So, let's talk first about normal strain. So, what is your normal strain? Your normal strain is just simply denoted by small Greek letter epsilon. Alright, that's mo na iyahang denotation, epsilon. So that is defined as the deformation of the bar divided by the original length. Mo ginihim dumi, alright? Mo gini ato ang working equation for normal strain. Deformation divided by the original length. So let's talk about the formula. So for example, kaning atong figure sa ubos, alright? Kaning figure sa ubos. If ang ato ang axial load mo ni atong original member, di ba? LO. Right? Our original length. Now, after the application of our axial load P, right, the length of the bar will change from your LO, which is your original length, to L, which is our final length. Now, deformation, that is denoted by small letter Greek delta, right, kaning delta nato, that is the change in length of the material. So, by using the formula, basic, that would be L minus L sub O, or our final length divided by the original length. Wait. Okay. So, therefore, our normal strain can be expressed as deformation. Diba? Deformation divided by the original length. So, therefore, deformation is equal to gamma. delta divided by the original length, or our L sub O. So delta divided by L sub O, and we can express this delta as L minus L sub O. So therefore, this would be our final formula for strain. L minus L sub O over L sub O. Okay. So I hope that's clear. So siguro simple naman siguro ng explanation. So because the deformation is a unit of length, diba? Deformation is length. Say for example, meter. Tapos ang ato ang original length is meter pod, diba? So length over length, makancel siya. So therefore, our strain is a dimensionless quantity. Hinumdumi na siya, dimensionless quantity. Pero some of our problems, kasi makakita mo nga, the strain is equal to 0.004 mm per mm. Pwede na siya, mo na siya usually ginagamit. mm per mm. Gina-express lang niya nga, in every millimeter na ay deformation nga 0.004 millimeter. So, millimeter per millimeter. So, kung imo siya, mathematically, makansel na siya, mo na siya gitawag sa dimensionless. Pero sa ato mga problem is usually, mo na siya nakabutang length per length. Okay? Length per length, gina siya pagka-express. Okay. So, however, it is sometimes stated in terms of a ratio of length units. Mo to kong ingon. Now, say 480 micrometer per meter. So, micrometer per meter mo na siya. Micrometer, mas gamay pa siya sa millimeter. Micrometer. So, say 480 micrometer per meter. So, yan na siya pagka-express. Depende. Micrometer man usually, pero most of the problem is nakabutang na siya. So, since strain is a very small quantity, it is usually expressed as micrometer per meter. Alright? So, 1 micrometer is equal to 10 to the negative 6 10 to the 6 meters. So, smaller than a millimeter. For example, we have a deformation of 6.5. Diba? 6.5 nga millimeter deformation. Tapos, we have an original length of 1.5 meters. So, therefore, we can solve your strain. So, your strain would just be the deformation over your LO. So, that would be 6.5. Then, this would be 1,500 mm, diba? Para makancel. This would be mm. So, ang mahitabo karon diri, this would be 0. This would be 0.0433 meter per meter. Okay? So, kung ato na siya na may usually nga in percentage na siya. Percentage elongation or percentage contraction. So, ato lang siya i-multiply by 100, mahimo na siyang 0.433% elongation. Meaning, 0.433% ang change sa ato ang material. Okay? So, kung nata kaning atong 6.5, that is simply 0.433% of our 1.5 meters. Malangyan na siya. And then, okay, mula na siya. So, pwede naman siya i-convert to micrometer if ganahan ka. Pero usually, malangyan niya ato ang expression. Okay? For strain. So, for our sign convention, elongation will always be a positive strain. Para sa itong stress ba? Ang ato ang tensile stress would be positive. Ang ato ang compressive stress would be negative. So, the same hapon na sa ato ang elongation and contraction. Okay? So, contraction meaning mimubo, elongation meaning mi taas. Alright, so for our second strain, that would be our shear, right? Shear strain, that is denoted by small Greek letter gamma. That is defined as the change in angle. Okay, so karon medyo basin mag-wonder mo ba, nagsugod-sugod na og daghan na ato ang mga Greek letter. For example, sa gamma, you have encountered last semester gamma is the direction angle, right? Direction angle for the z-axis, diba? So, daghan pa na gamma, pwede pa tamahimong unit weight si gamma. Okay, pero again, every course, every subject, alright, every nga field, alright, dapat kabulan na mo kung unsa na siya nga denotation. Alright? So, for strength of materials, we will be talking gamma for shear strain. Okay. So, So shear strain, defined as the change in angle that occurs between two line segments that are originally perpendicular to one another. Muna akong ingon nga, king rectangle ni siya, right? Kung rectangle ni siya, that is in 90 degrees. So pi over 2, so yung ano naka pi over 2 man na siya. Because, since strain is a dimensionless quantity, we will be talking here with radians. Okay, radian is a dimensionless quantity mo po na siya for angles. Right, for angles, that is a dimensionless quantity. So we will be expressing angles here in radian. Right, so 90 degrees meaning pi over 2. So if always measured in terms of radians, which is a dimensionless unit for angles. So using the above figures, shear strain can be solved mathematically as pi over 2, which is our original angle. Original angle minus the final angle. Right? So, final meaning, pwede siya may gamay, pwede siya may dako. Sorry. Okay, so that is our formula. Gamma is equal to pi over 2 minus theta. So, pi over 2 na siya, meaning 90 degrees or perpendicular sila before. Alright? So, sign convention. If the shear strain is positive, meaning ang angle is midako. Right? Midako siya. Migamay. Sorry. Migamay. Shear strain is positive, meaning your theta is less than pi over 2. So, migamay. This would be our positive shear strain. So, mi acute angle siya. Right? Mi acute. For the negative shear strain, that would be mas midako siya. Right? Midako ato ang angle. So, I hope nga klaro ra because this is in preparation man god for module 3. So, this would just be a very, very short lang siya nga discussion. Okay? So, most engineering designs involve applications for which only small deformations are allowed. So, for normal strains, our sigma. Epsilon. Our epsilon are infinitesimal, meaning strain is much lesser than 1. So, mas gamay pa siya sa 1. So, gagmay lang yun na siya kaayo. Now, for angles, also gagmay po kayo nato mga change in angles. Mauna ang ato ang mga trigonometric identities is almost equal. So, kung kaunin mo si sine angle, that would be equal to cosine angle, and that would also be equal to tangent angle. Tungod sa kagamay na siya. Okay? So, wala na siya. I guess that's the end of this video. Okay? That's the end of this video. So, medyo very short. Alright? So, I hope nga klaro ra for this module. And the good news is, alright, what's the good news? Okay, so no assessments for this module. So, I will just be releasing your problem sets, right? Your problem set number 2. And then, it doesn't mean nga dili na included sa to exam. Alright? It doesn't mean nga dili na included sa to exam. Some problems nga gikan sa problem set would be included sa ato ang mga major exams. So, pero di mo siya kayo liso, diba? Because the formula is very, dali na mo siya hinumduman. Right? Dali na siya hinumduman. But for this module lang, wala tay assessments nga mahitabo. Alright? So, problem set lang, and then, just study, just do your problem set on your own. Basin mo gawa sa ato ang major exams. Alright? So, I guess that is the end of our module. Alright? That's the end of our module 2. So, let's continue on our next video. Alright? So, bye yours.